Welcome to Mickey's Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of lines. Coming to the problem statement. The front view of a 90 mm long line, which is inclined at 45 degrees to the XY line, measures 65 mm. The end A is 15 mm above the XY line and is in VP. Draw the projections of the line and find its inclinations with HP and VP. So, looking at the problem statement, we can arrive at a set of conclusions. That is, the top view line is not given to us, but the front view of a 90 mm long is given to us. So, the true length of the line is 90 mm, and also the front view of this 90 mm long measures 65 mm, and also its true inclination is 45 degrees to the xy line, that is the reference plane, and the end A is 15 mm above the xy line, so which tells that it is 15 mm in front of HP, so that we are going to record the top view and doesn't VP. We need to draw the projections of the line and find its inclinations with respect to HP and VP. So we'll begin the problem by drawing the XY line of thickness 0.18 mm. So we will draw the XY line of any arbitrary length measuring 0.18 mm in the thickness. And we will annotate this line as the reference line. So this is X and this is Y. And the plane above the XY line is vertical plane and the plane below the XY line is horizontal plane. So now with this data, we will move on to the next set of data that is available with us. The end A is 15 mm above the XY line. So it is 15 mm above the XY line. So we need to draw that projector using 0.13 mm as the thickness, and the length is 15 mm above the XY line. So this data is given to us. So we will plot this data. So this is going to give us the front view of the point A, and I will annotate this as A dash, and also draw the locus of this point A in the vertical plane. So locus line will be a line parallel to the XY line, and this is locus of A in the vertical plane. And it also tells us that one of the point is in VP, so it is on the XY line. So this is A dash, and this point is A. That is the top view of the point is recorded on the horizontal plane. So he also tells us that the true length is 90 mm long and is inclined to the reference line at an angle of 45 degrees. So the value of theta is given to us. And so this data, we will draw the true length of the line. So the true length of the line will again be a 0.13 mm thickness line. So it is 90 mm in length, and the angle of inclination is 45 degrees. It should be a continuous line. So change the line type to continuous line. So from the end point, we are going to draw the locus of one more point, that is end point, that is B. So we will select the locus line. So we'll draw a line passing through this point and annotate this line as locus of B. And this point is B1 dash. And the angle between this line and the locus line is 45 degrees. So either the locus line or the reference line, it is a line parallel to this. So we can just annotate the angle as 45 degrees with respect to the locus of A itself. Okay. And now we also know one more data, that is the front view length of this line, that is a dash b dash, is how much? 65 mm. So we will see how it is 65 mm. So before that, we will just try to complete this projection. So from endpoint b1, I will draw a line parallel to the xy line, and I will draw the top view of this point, that is b1. And then I will select the arc by center point, and then draw an arc taking the radii as AB1. So I'll draw an arc of infinite length. So I do know that the locus of B shall intersect with this arc at some point. But how to find out that point of intersection? So what I can do is I can plot the front view of the line, which is given as 65 mm. So let me go for the line option again. Select the continuous line of thickness 0.50, and from A dash I will be drawing a line of length 65 mm, and I will ensure that it has to intersect somewhere along this locus of B. If it is not intersecting, so just go for the extend to next option and extend the locus of B line. So you can just see that it is intersecting at this point. So I'll annotate this point as B dash. So this A dash B dash is the front view of the line AB, that is AB1. So this is the true length of the line, true inclination of the line. So now let us find out the apparent inclination, that is the value of alpha, as the angle between A dash B dash and the locus of A, which is 78 degrees. So the value of alpha is 78 degrees. And we do know that the projector line, that is from B dash to B, will be a straight line. So keeping that concept in mind, let me draw a projector line from B dash and intersect that with the arc that I've already drawn earlier. So the top view of the line, the apparent view of the line in the horizontal plane, shall be here to the point of intersection. So this is the measurement, and then we will measure the apparent angle, one more angle, which is 78 degrees again. So the value of alpha and beta is equal to 78 degrees. So we need to find out the value of phi. For that, we need to draw the true length of the line in the horizontal plane. So let us annotate this point as B, and let me draw the locus line of B in the horizontal plane. So I'll select a line of thickness 0.13 and a locus line. So I'll be drawing a locus line which is parallel to the xy line. I will annotate this line as locus of B in the horizontal plane. So now to draw the true length of this line, that is AB in the horizontal plane, what is the procedure that we need to follow? So we do know that A dash B dash is here. So this is A dash B dash. So this is A and A dash. So this point. So first we will consider this A dash B dash and try to reverse the concept, that is keeping the front view of the line AB as A dash B dash. We will try to draw an arc which is going to cut and be parallel to the xy line, and then complete drawing the true length of the line in the horizontal plane. So for that, the procedure is I'll select the arc by center point. I will measure A dash to B dash and draw an arc until it is parallel to the locus line, intersecting the locus line. So from this point, I will be drawing a line to intersect the locus of B. So again, this should be a continuous line. So now I can draw the true length of the line. So ensure it is a continuous line of thickness 0.13. So from A dash to the point of intersection of the locus. So you can just see that it is 90 degrees and the value of phi is 43 or 44 degrees. So this is the procedure. So you can just see that this is 90 mm, and the angle of inclination of the true length of the line with respect to the reference line is 44 degrees. So this completes the problem. So what we did here is uh, we represented this as B2, and this is A dash B2 dash, and then drawing this gave us the front view in the actual procedure. But in order to get the true inclination in the horizontal plane, we are going to reverse the procedure. So let us show the indications of the projector lines by selecting the leader option. Click on properties and change the arrow mark color to black, and now we will indicate the directions of the arrow mark. So this is the direction in which we have drawn the arc now, and then a projector line downwards. And here it was the reverse procedure. So we drew the projector downwards, and then the arc was drawn in this direction to get the top view of the line, that is AB. So with this we complete the problem. So we will just try to adjust the points of annotations, that is A and B, so that they're not intersecting with any of the lines that we have drawn. So to sum up, the value of alpha is 78 and that of beta is also 78. The value of theta is 45, which is already given to us in the problem statement. And the value of phi, that is the true inclination of the line with respect to the vertical plane, is 44 degrees. That is the value of phi. And then the true length is 90 mm, which is already given to us. And then the apparent length in the front view is 65 mm, which is already given to us. And the apparent length of the line in the top view is 63.64 mm. So with this we have completed the solution for the given problem statement. Thank you all for watching.